Welcome back to All This Math. This is Professor Parker, recording live from my office at Cheyney University. And if you haven't done so already, please go ahead and subscribe to the All This Math YouTube channel. Please turn on the post notifications so that when I put out new content, you'll be the first one to know. Also, and as you probably have already been doing, please continue to tell people about All This Math and what we're doing here on the YouTube channel. So, with that being said, let's get into today's lesson. So, what we're doing today is something called estimating square roots. Estimating square roots. Now, you might be wondering, like, why would we need to estimate what a square root is when we have calculators? When we can just type in, for example, we can just type in 68, hit the square root button, and then boom, we'll get a nice little decimal that will tell us what the square root of 68 is. Same thing with the square root of 13. But what if we don't have a calculator? Or what if we are taking a standardized test where we're attempting to complete a section that does not allow for the use of calculators? We need to know how to estimate square roots. And also what I will say too is that estimating square roots is kind of a popular skill on a lot of math standardized tests throughout the country as well, or throughout the United States as well. So you want to know how to do this skill. And it's not that difficult, really. It's not that difficult. It's kind of helpful. It can help you in many other types of more advanced and more complex mathematical operations as well. So there's a couple of steps to it. Let's start with number one. Number one, we have the square root of 68, right? Take my marker out. So we got the square root of 68. All right, now, first question is, whenever we see a square root symbol or radical sign, we want to think about, is this number inside the radical sign, which is called a radicand, R-A-D-I-C-A-N-D, radicand. 68 is a radicand. Is it itself a perfect square? We say no. We know that it's not a perfect square because there is no whole number that you can multiply by itself which will equal 68. There are numbers that you can multiply to equal 68. For example, you can do, 17 times 4? 17 times 4 equals 68. But 17 and 4 are not the same number. So when we have what's called a perfect square, that means that we have a number that we result in, that we end up with when we multiply any whole number by itself. Not a decimal by itself, not a fraction by itself, not a mixed numeral by itself, but a whole number by itself. All right? Must equal that. So 68 is not a perfect square. Now, we want to estimate what the decimal value of this is. Now, we're not going to simplify it by essentially like breaking it down, and pulling out a perfect square factor of 68. That's not what we're doing right now. We're going to estimate, what the decimal equivalent of this is. So when we say estimating square roots, we're talking about figuring out what the decimal equivalent would be. And something close to it. We might not be exactly right, but that's cool because we're just estimating. We're trying to get an idea of what it is. So first thing you want to do is this. You need to know your perfect squares. I'm going to just put it out there straight like that. You need to know your perfect squares. You need to know your multiplication facts from 1 times 1 up to 12 times 12 at a minimum. That's the minimum. Ladies and gentlemen, boys and girls, that's the minimum. You need to know 1 times 1 all the way up to 12 times 12. All right, and if you know that, then you'll know the perfect squares from 1 up to 144, right? 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on, all the way up to 11 times 11 is 121, 12 times 12 is 144. You know what I mean? So, dig it. We got 68. You want to think to yourself, actually, let's do it like this, right? I would say draw 3 spaces like that on your paper. Draw 3 spaces like that. In the middle space, we're going to put 68. 68 is our radicand. Now, I want to think of a perfect square that's less than 68 and a perfect square that's greater than 68 and that are closest to 68. So I don't want to think of like any random perfect square less than 68 or any random perfect square greater than 68. I want you to think of the closest 2 perfect squares to 68, one being less than, one being bigger. Since I know my perfect squares, I know that 64 is the closest perfect square to 68 that's less than 68. 64. So I'm going to throw a 64 right here. And I also know that the closest perfect square to 68 that's bigger than 68 is 81. So I'm going to put the 81 right here. All right. So I got 64 and 81, right? You're going to see why I'm doing this in a minute, right? Now, we're going to rewrite these as square root of 64, square root of 68, and the square root of 81. So now we back to the square roots. Now, dig this, right? If 68 is more than 64 and less than 81, then it also stands to reason that the square root of 68 would be more than the square root of 64 and less than the square root of 81. Just think about how these numbers are positioned relative to each other. Think about how they would be on a number line, right? If this is in between this and this, then this, the square root, should also be between the square root of this and the square root of this. That's the logic right there. Once you understand that logic, then estimating square roots becomes easy. But you just have to understand this logic. If I know that 68 is more than 64, I know that 68 is less than 81, then I also know that the square root of 68 has got to be more than the square root of 64. And the square root of 68 has got to be less than the square root of 81. Now, let's keep it moving. What is the square root of 64? That's a plain old 8, because 64 is a perfect square. What's the square root of 81? That's a 9. Now we're about to figure out what the square root of 68, or at least estimate what it should be. We know that the square root of 68 got to be between 8 and 9. So it's going to be more than 8 and less than 9. So we getting close. Right? It's got to be between 8 and 9. Now, the question is it close to the middle, the halfway mark between 8 and 9, like at 8.5? Or is it less than 8.5, or is it more than 8.5? This is how we figure that out. Go back to the original three numbers, 64, 68, and 61. Ask yourself, how far is 68 from 64? It's off by 4. Now, how far is 68 from 81? That's off by like 13, right? Because 68 plus 13 is going to be 81. So with that in mind, now we know that 68 is closer to 64 than it is to 81, because 68 plus 13 is 81, but 68 minus 4 would be 64. So 68 is closer to 64. So this helps us to know that the decimal is not going to be 8.5, because it would be 8.5 if it was halfway between 64 and 81, and it's not. It's not halfway between. If it was halfway between, then this would be equal to 8.5, right? But because 68 is closer to 64, remember, think about the number line. Visualize the number line in your head. Because 68 is closer to 64, that means the square root of 68 is closer to the square root of 64. So therefore, we can estimate maybe like, I don't know, I might say like 8.3. That's probably what I do. I say 8.2, 8.3. Oh, my marker's running out. I'm going to say 8.3. That's going to be my estimate. My estimate is 8.3. That's what I'm going to say, right? I know that it's less than 8.5 and it's more than 8. So I'm going to just say 8.3. It might be like 8.2, something like that. But remember, this is just an estimate. We're estimating square roots. We don't have to know the exact value. If we want the exact value, we break out the calculator for that. So this is a good estimate, 8.3. All right, now let's go over instead of me recapping what I did in number 1, let's go over to another example. Let's look at another number, the square root of 13. All right, now let's follow our same steps, square root of 13. Now first, before I write anything down, is 13 a perfect square? That's our first question. Is 13 a perfect square? The answer to that is no. 13 is not a perfect square. We know that. 13 is not a perfect square. All right, so write your 3 blank spaces. 1, 2, 3. All right. Take the radicand, 13, put him in the middle. All right. Now, think to yourself, what are the 2 closest perfect squares to 13? The closest one less than 13 is 9. So throw the 9 right here. What's the closest one greater than 13? 16. Put the 16 right there. 13 is in between 9 and 16, right? So now we go back into square root mode. So now I got the square root of 9 and the square root of 13 and the square root of 16. Right? Now the square root of 9 is 3, because 3 times 3 is 9. the square root of 16 is 4 because 4 times 4 is 16. Now, question is, so now we know one thing. One thing we know is that the square root of 13 must be between 3 and 4. It's got to be. It's got to be between 3 and 4. We already know that. That's a given. Now the question is it less than 3.5 or is it more than 3.5? Because we don't need to be exact, but we want to be as close as we can get to the correct decimal value, right? So check this out. I need to go back up here. What's the difference between 9 and 13? Plus 4. What's the difference between 13 and 16? Plus 3. So now the question for us is 13 closer to 9 or closer to 16? Is it closer to 9 or is it closer to 16? It's closer to 16 because I only got to add 3 to get to 16, but I got to subtract 4 to get to 9. So it's closer to 16. So that means that it's between 3.5 and 3. It's between 3.5 and 4, right? But it's almost halfway. It's almost at 3.5 because, you know, having to go up by 3 or go down by 4, 13 is almost halfway between 9 and 16, but not quite. So my estimate is going to be, I'm going to just put it at 3.6. I'm going to put him at 3.6 like that. That's what I'm going to do. All right. Now, I hope that makes sense. But remember, the steps that we have to go through is basically just, you know, think about what the perfect squares are and do yourself a favor. If you don't know the perfect squares, go memorize the perfect squares. Go to a 12 by 12 multiplication table. You can find one in the back of a black and white marble composition notebook. Just memorize those. Write those multiplication tables down. I got templates on the allthismath.com website that you can print out. Go to the website. You can print them out and have your children do one every day. Fill them out. You know what I mean? I got 12 by 12s and I got 15 by 15s. They should have the multiplication facts memorized. Do yourself a favor or have them do themselves a favor, right? Once you know that, you'll know what the perfect squares are. So you'll know that 9 and 16 are the closest perfect squares to 13, right? You'll know that. Once we know that, then we know, okay, well, take the square root of 9. It's 3. Take the square root of 16. That's 4. So I know that the square root of 13 has to be between 3 and 4. It's got to be. It's got to be between 3 and 4. That's just a mathematical reality that we can just accept. But then the question is it less than 3.5 or is it more than 3.5? We know that this is going to be more than 3.5 because 13 is closer to 16. So that means the square root of 13 will be closer to the square root of 16 than it is the square root of 9. But not by that much because 13 is 3 away from 16. It's only 4 away from 9. So it's kind of, it ain't like number 1, the first example, where 68 is like a whole 13 away from 81, but it's real close. It's only 4 away from 64. So you know that it's a lot closer. Square root of 68 is a lot closer to the square root of 64 than the square root of 81. I probably could have took it down to 8.2. But you know, we can grab a calculator at some point, or you can grab a calculator and check to confirm. But it's probably like around 8, might be 8.2-ish, 8.2, you know, closer to 8.2. But anyway, this is cool. And this is a little lesson on estimating square roots. And I hope you learned something. And again, if you have not subscribed to the channel, please subscribe to the channel, turn on the notifications. And as always, do remember that there's all this math all around you. Peace.